right, let's get started here. My name's Jim Anderson. I've been a faculty member here for 22 years, and yet a good number of you, I don't know you. So you must have been here before me. We have 3 distinguished alumni giving talks here in this session. I've been told that my really sole purpose here is to make sure that this all happens on time. So, the first speaker is Anne-Marie Fred, and Anne-Marie did her undergrad work at a school in Durham. Then decided to upgrade to a better shade of blue for grad school. Finished a master's degree here. Has been at IBM as a software engineer since 1998. Says here your favorite subjects here were mobile computing, web applications, algorithms, distributed systems, and software engineering. Also says you are a DevOps evangelist, and I think we're all about to be evangelized. Take it away.
Thank you very much. All right, so yep, you've heard a little bit about me already. I graduated from here in 2005 and kind of focused on distributed systems and software engineering while I was here. And I've been at IBM since 1998, so that's before I graduated from undergrad. I just kind of started as a co-op and kept going. And the divisions I've worked in included pervasive and mobile, web applications, systems management, and most recently cloud computing. And I've been on teams that really focused on DevOps since 2011, and that's 5 different teams. So either DevOps or continuous delivery was like a core focus of the team. So for those of you who might not be familiar with DevOps, it is a philosophy and a set of principles and practices. If you start by thinking of it as something like Agile, but continue it to the production delivery, that'll get you on the right page. And the goals of DevOps are, first of all, happy developers, happy IT operators, happy business stakeholders, and happy consumers. So how do we achieve these goals? Well, here are some things that happy developers like. So they like work-life balance, fun, passion, applications that stay up, the quality of the application. They like to move fast. They like to deliver business value, share their knowledge and experience with others, grow broad and deep technical skills. They like clear communications, and they like to continuously improve their processes, the way they do their jobs every day. And what makes ops happy? Well, it's actually pretty much the same stuff, but maybe not velocity, because when things change quickly, it makes it harder to keep things up and running. And what makes a business happy? Actually, it's all the same things that developers like. Velocity is in there, and they like agility. So they like to be able to change the requirements on a moment's notice and have those changes be reflected in production quickly. Developers don't actually like that. They like a plan and to execute on it. And what makes consumers happy? Actually, it's a lot of the same things again. They like fun, passion, uptime, quality, agility, velocity, business value, and clear communications. So I think you'll probably sense a theme. And this is how we get to the core values of DevOps. I'm not going to read them again, but there they are. And I'm going to talk about each of these in a little bit more detail. So a lot of times when groups try to adopt DevOps, they're a little bit overwhelmed. Like in IBM, you know, it took us a long time to switch from a waterfall model to an agile software delivery model. And now we're going from an agile software delivery model to a DevOps model. And it's going to take a long time again. And some teams have farther to go than others. So you start to ask yourself, well, what do you have to adopt all at once? Which things are interdependent and require each other to work? And what can you sort of put off or make optional? And so that's what I'm going to talk about here. So first of all, here are the warm fuzzies: work-life balance, fun, and passion. First of all, you need to attract and retain talent to your team. And you have to hire for people who care about the warm fuzzies. You want to find people who are passionate, people who want to have a life outside of work, and people who like to have fun. On my current team, you know, we like to put the Pandora music on loud every once in a while and dance around. We have a pool table. We have video games. And you know, that's the type of person that we try to attract to our team. We also assess management on the warm fuzzies. So is your team happy? Are they having fun? Are they passionate? Do they have energy? Do they want to come to work? And you have to consciously make these things happen. So, do the team outings, do the fun things after work, let people be a little silly and crazy at work sometimes. And the other DevOps core values help immensely. So if you're always under a lot of stress and pressure because everything is breaking, you're not going to be happy at your job. So clear communications, here are a few things that you absolutely have to make DevOps work. First of all, you have to talk to each other. Goes without saying. You need good chat services. So we use one called Same-Time Instant Messaging a lot within IBM. We also use one called Slack, which is awesome, which is more like IRC crossed with chat with a history, and it's searchable, and you can paste things into the window. We have wikis and blogs for sharing anything that has to last a longer time. And we have forums, of course, where people can come and ask questions. We have bug reporting and tracking systems, that's pretty fundamental, and some kind of agile planning and tracking. So what are the extras so far as communications go? Co-location is awesome. It's best if you can get everybody in the same room or on the same campus, but it's optional. I've been on DevOps teams where people were on different continents. It works, you just have to work harder at the communication, and you have to have good communication tools like video screen sharing and things like that. Social media is great for outreach activities, Facebook, Twitter, all that kind of stuff. I actually get to do some of that as part of my job. Conferences, also plus. User groups and meetups, of course. Email and newsletters are actually pretty far down the line for communications. We don't use them very much for internal communication in our team. And specific agile technologies are optional. So basically, it doesn't matter what you choose. You can use Scrum, you can use Kanban, you can use some, combination of the two that you made up for your own team, as long as it works for you. So the next topic is about sharing knowledge and experience and developing broad and deep technical skills. First of all, you need everything on the clear communication side to make this work. Another thing we need to do is document as we build things. Now, this is not at the level of code comments. We actually avoid those. We try to write the code so you can read it without a lot of comments. But we do document how we implemented things and why we implemented that. And basically, the rule of thumb is if more than one person comes and asks you a question, then you should probably put up a wiki page or a blog post about it so you can train more people more quickly. There's also plenty of informal training, stuff like this, or if, just a conference call where people talk about something they've learned about. Of course, there are internet resources, and then code reviews. Those are the most important aspect, I think, of knowledge and experience sharing. So basically, when somebody submits a change to our Git repository, it gets reviewed by at least 3 people, but more often 5 or 6 people on the team. It has to have a +2 from one of the committers on the team, one of the more experienced developers, and it also has to have a +1 from somebody else who is not the person who submitted it. Our code normally goes through at least 5 rounds of reviews and revisions, even if it's just a 1-liner or a 2-line code change, and it's not unusual for it to go through 10 or 12 or 15 revisions. So our team is very careful about the code, and it's a way to teach people how to do things right. Some things that are helpful. One is that you can work on things you don't know how to do. So what we do when we break down a story that we're going to work on for the week, and we have all the tasks in a priority order, if you see multiple tasks that are available and you're not sure which one to pick and they're all the same priority, you're supposed to grab the one that you don't know how to do and then ask somebody to pair with you, and people are happy to do that. Which brings us to pair programming. Next to code reviews, this is the best way to share knowledge and experience. Just literally stand next to somebody and have the person who's new basically do the typing, and the person who's more experienced will help them along. Cross-pollination is where we take somebody from one team and let them sit with another team for a week, and then they trade back. The open source model is very helpful. So this is where you open up your source code to anybody in the company or anybody in the world, in the case of true open source, and you encourage them to make contributions to your code. And the reason that it doesn't break everything is because you have those code reviews in place. Finally, there's formal training, which we do very little of, actually, but it's out there. And sometimes it's helpful if you have to learn a lot in a small amount of time, and books. All right, so the next value is uptime. So what do you absolutely need for uptime? We're going to talk about quality next, but you absolutely need quality code. You need good monitoring. If you don't know when your system's down, there's nothing you can do about it. So the last time we had an outage was probably a month and a half ago. We knew about it within 60 seconds, and everybody on the team went to a conference table and fixed the problem immediately. Graceful failover is important. So actually, we deploy onto 2 platforms. It's not uncommon for one of them to be down, and you just don't notice it as a consumer because it just fails over to the other one. Sharing the pager. So on my particular team, the people who develop the code are the same people who operate it. That's ideal, but if you can't do that, you at least need to rotate your developers through. And what this gets you is developers who care about operational quality characteristics like uptime and performance and so on. Postmortems, blameless postmortems are key to the whole DevOps concept. So when there is an outage, it is the duty of the team to analyze what caused the outage and write it up and share it with everybody else. And that is, the purpose of that is not to beat anybody over the head with what they did wrong. It's to learn from the experience and make sure it doesn't happen again. And finally, continuous delivery. Now this one, I really struggled with whether it's required or not. I've worked on teams that sell shrink-wrap software that only goes out to customers every year or so. And they can do a lot of DevOps, but if there's a problem in production at a customer site, they're not going to be able to get it up within an hour because they're not going to be able to deliver a patch within an hour. So I put it on the required. And continuous delivery, there are books written on this that are fantastic. Just for anybody who's not familiar with it, I'll go over it really quickly. So continuous delivery is automated deployment into production. It means that you have deployment automation and you code your infrastructure so that you can store it as source control and revision control it. It means frequent deployments, ideally several per day. So my team does between 5 and 20 deployments a day. It means you make small incremental changes, 1 or 2 lines of code at a time, and 0 downtime, which means you have to have a way to sort of roll out changes without breaking the system. In our case, we just do blue-green deployment, so we bring up the new system and make sure it's OK, and then route the traffic over to it. You also have to have automated testing in production, or at least in a staging system that's nearly identical to production, including non-functional requirements like performance and drop-off. And you have to have some kind of stage rollouts, maybe dark launches, rolling deployments, A/B testing, green-blue deployments, and that kind of thing. So it's hard, but it's extremely valuable. Uptime, some of the things that are great for uptime are, of course, sharing knowledge and experience, right? The more people know about the system, the faster they can fix it. Graceful degradation. So like I said, if one of our deployment platforms is down, the other one's going to take over. And a dedicated support team is helpful, but it's not necessary because you can have your developers be the same people who are supporting the system. All right, so the next topic is quality. So what do you absolutely need to have quality software in production? You need bug tracking, obviously, source control. You need code reviews. There's no way one person's going to get it right every time. You need security testing, because if somebody can hack your system, it is not a quality system. Continuous integration. So continuous integration, I think, is on the next slide, and then continuous testing. And continuous integration and continuous testing are things you can easily do if you do not deliver to production on a daily basis. Continuous integration means that on every check-in of source code, you automatically build the code, you test the source code automatically, you do some static code analysis where you check like for linting, formatting errors, that kind of thing. You run API tests and anything that doesn't require a running system, so that can be run right on the developer's laptop. And then you package the build artifacts for deployment and store them in a library. And continuous testing is the next phase. So you retrieve the build artifacts from the library, you deploy them automatically in the lab, and you want that lab to be as close to production as possible. You automatically test the running systems with another test suite, and then you report the test results quickly. You can have voting and non-voting tests. For example, if you have some new features that are expected to fail for a little while, you can make them non-voting as long as they're hidden features that nobody can see. Failed voting tests will make the build fail, and if the build fails, it's the developer's obligation to fix it before moving on. Ideally, this entire continuous integration and continuous testing pipeline should take no more than a minute or 5 minutes. On huge systems, it may take longer. I've been on some where it took an hour. If it takes much longer than that, people are going to give up and break the last rule and move on to the next thing. So we really focus a lot of effort on trying to keep that fast. And some extras for quality are, of course, knowledge and experience, broad and deep technical skills, and continuous delivery is very helpful. So continuous delivery allows you to deliver a fix to production very quickly if there is a problem. Next, we have agility. So what does it mean to have a team that can change directions quickly? Well, first of all, you need clear communication. So you need everybody to be on the same page as to what the change is that you need. You need the agile planning and tracking to help with that. You need frequent releases. The more frequent, the better. Obviously, if your release cycle is 3 months or 6 months or a year, that's as agile as you can be. If it's 5 minutes, you're way more agile. You need short feedback loops. So you need people who are out monitoring Twitter, monitoring the forums, monitoring the automated monitoring tools. And you need autonomous, empowered teams. You shouldn't have to ask permission to make a change. It should just have to go through the code review process. And here's a quote from somebody on my team about quality and agility. So Rick says, Agile has not only improved our ability to plan effectively, but it also has allowed us to spend more time working on user stories by improving the quality of the code we deliver. So, several years ago, I was on teams where as much as 30 to 50% of the time was spent fixing old bugs. If you spend more time up front, you spend maybe 5 or 10% of your time on old bugs instead. And next, we're going to talk about velocity. So this is how quickly you can get changes to production. With DevOps, the velocity is going to be very slow at first. It takes a long time to build out a tool chain like this. So you start with little tiny changes, and you're spending most of your effort on the tool chain at first, for the first few months at least. Then over time, it's going to get faster and faster because, like I said, you're not spending 30 to 50% of your time fixing old bugs. You're spending 5 or 10% of your time, which leaves all the rest of the time for new features. It keeps that bug count low. It keeps the technical debt low, which is a combination of bugs and things that you wish you had written into your software but didn't have time before. And also, you need to have frequent releases to get velocity. So, if you're developing in-house and you've delivered 100 features but nobody has seen them yet, to the consumer, there's no value yet. And here's a quote about agility and velocity. By having daily Scrum meetings, everybody knows who's working on what, resources quickly get directed to problem areas, and impediments are addressed quickly and efficiently. And finally, business value. So in order to deliver business value, remember, they require that you have uptime, quality, agility, and velocity. You also have to have the right stakeholders. So sometimes everybody in the business wants their fingers. You can only have like one chief, and you can only have a few stakeholders, right, who are feeding in on exactly what needs to happen, especially if you're talking about something like user interface or a website where everybody has an opinion. You need to have user-centered design, of course. Otherwise, developers don't always, they think like developers. They don't think like everybody else. You have to evaluate teams on the value that they deliver to the business. Otherwise, they're just going to make up their own metrics, and it might not be the ones you want. And finally, you monitor the business value. Do you know how many new customers are coming to the website every day, every hour? If you don't, then how do you know that your change that you just put into production made it better or worse, right? And here's a quote on agility and business value. As a product line manager, working on 1-week sprints gives me the flexibility to change priorities as things change. I can still get the big ticket items delivered, but I can do so without getting locked into an unyielding plan and can react rapidly to shifting business priorities. So he's our chief product manager. And finally, continuous process improvement. So this is how we make our day-to-day jobs better. If something didn't work last week, how are we going to fix it this week? We do this in 2 main ways that are really key. One is the blameless postmortems that I already talked about, and the second is the sprint retrospective meeting. So every day, at the end of the day on Friday, we all get together and we talk about what was fantastic about the last week. Then we talk about what went wrong, and from those we have action items that we commit ourselves to doing something about in the next week. So usually we'll have 5 or 10 things that were great, 5 or 10 things that were bad, and maybe 3 or 4 action items. So that's everything I had to talk about. I hope you enjoyed it. If you would like to reach me, I have my email address up there and my Twitter handle. Those are the best ways to reach me. I love the Triangle DevOps meetup group, so if you want to learn a lot about DevOps, you can join that. Just go to meetups. And DevOps Days conferences are a great way to get a fire hose of information about DevOps. They're around the world. You can probably find about 1 every month. Code as Craft, the blog by Etsy, is about DevOps. And there are also great blogs from Netflix, Facebook, and IBM on this topic. And O'Reilly Media publishes a lot of great books on things like DevOps and continuous delivery. Finally, we are hiring big time in my group right now. So if anybody's interested, send me an email, and I'll forward your resume along. Thank you. We have about, I don't know if we have any time for questions.
Yeah, we have time for questions.
I think I got in first. So my experience is that developers have a different concept of quality and uptime than ops people do. Right? So quality is, it works for me, it works in my environment, or it may be complicated, but it can be, no, it works fine, you're just using it wrong. Well, you haven't.
Right.
There's still a gap there. So how do you instill an ops view of uptime and quality to a developer? And that also ties into the communications and documentation. It's like, well, I understand it. And you said, well, we don't really do a lot of commenting code. The code should be readable. Right. Someone, on all the way to the consumer end, right, to the business value, they're not going to be reading the code. So how do you bridge those gaps?
Right. So yeah, there's a saying that operations are the firefighters and developers are the arsonists, right? Yeah. Basically, the best things that you can do, the ideal thing is to have the developers be the people who operate the software. Now that's not always practical, but in a startup environment, or if you're running a website or something like that, you absolutely can do that. A second great thing is if you take an operations person and embed them on the development team. So if they're sitting in the same area with the same 4 or 5 people, they talk to them every day, they hear what's going around in the room, and they share their perspective every single day, right? So when they hear about changes that are going into the system, they can ask the question, is this going to break something? Have you thought about security implications and things like that? And then the third option is to rotate people through. So have people spend, a week or a few weeks in operations every now and then, the developers, and have the operations people spend some time actually developing code so that there's that transfer of information and what's important between the different teams.
And a quick follow-up. Do you have, so basically everything you've talked about is process. Mm-hmm. Right? Are there any technologies that you've found helpful? The emerging paths?
Mainly testing technologies. So for example, if you get people in operations to either write tests for operational quality or tell people how to write the test for operational quality, like what they should be testing for, that helps. Because if a developer introduces a change and it fails because the system is slower than it was last week, then they won't be able to introduce the change until they fix it, right?
One last comment I'll make. The book on DevOps, the book The Phoenix Project by Gene Kim,
Yeah.
highly recommend.
Yes, it's a fast read. I think I got through it in like 3 or 4 hours, and it's great. Yeah. The Phoenix Project, and if anybody couldn't hear that, over here. I think here. Okay.
Do you do automated code review? Any part of your code review, is that automated or is it all human?
Yeah, so we have automated tests, and we have source code linters, which check for style guidelines, like you're not allowed to use for loops, and you have to have things indented correctly, and things like that. Yeah.
So you're talking about documented as you go. How do you deal with obsolete documentation once ideas change as you go?
So yeah, ideally, that's why most of our documentation ends up in wikis, because people can edit those over time. So we don't put any value in keeping the old version of the wiki, just update it as things change.
Yeah, quick question was that you did, in the continuous integration part, you did not talk much about things like Zookeeper and all the other, there's a ton of stuff out there to automate and do things, right?
Right, yeah, for the last project on it was a big multi-node, it was 12 server system. And yeah, we did use Zookeeper and Chef to automate the setup of those systems. Chef is an infrastructure as code programming language. And actually, we found that absolutely critical because that's the only way we could guarantee that the setup steps in our development lab were the same as the ones that the customers were going to run.
I mean, I was also referring to where you would introduce a change only on a small number of instances and then see how they perform and then then continue to move it into production or not.
Right, and for the complex systems, we have huge test labs where we can deploy that 12 server system on every change. So there's a lot of hardware there, and it gets deployed on several supported topologies every time. And if it doesn't pass on all of them, it fails. That's the one where it takes like an hour to get a result back.
Do you have a copy of your presentation?
Yeah, I can send it.
I can send you, I mean, email.
Bill, are these things going to end up on the web?
We have a subset of the talks that are already up on the web. When we get permission from people speaking to distribute them widely.
Oh, okay.
And we can ask others. We also have the videos obviously too.
I think there was another question. Yeah.
Having worked at IBM for many years and being in testing for many years too, you made this comment about how you do this quick testing. And it sort of blows me away because when I was testing with WebSphere, we had to test a multiple operating system. It took a lot of time. It's like, how did you do this?
Yeah, I actually have a blog post on death by testing and lots of techniques for making it easier. I know one team that a friend of mine works on it. It used to take him 30 hours to do a build and test run. That was a horrible environment to work on. Yeah.
Multiple operating systems,
Yeah, there's a lot of tricks for that. Yeah.